Let's solve some implicit differentiation problems. First of all, we have this one. 7x cubed plus 2y cubed equals 4. And we want to find the derivative of y with respect to x. That means we're thinking of y as a function of x. So the derivative of 7x cubed is 21x squared plus, now the derivative of 2y cubed, remembering that y is a function of x, will involve the chain rule. So you got 3 times 2 is 6y to the second, and then because y is a function of x, the derivative of the base, the derivative of y, is dy over dx. And then of course the derivative of a constant is just 0. Now it's simply a matter of solving for dy over dx. So the first thing I do is subtract 21x squared from both sides. So I end up with 6y squared times dy over dx is equal to negative 21x squared. And finally divide both sides by 6y squared. And I get dy over dx is equal to, and notice there's a 3 as a factor of 21 and a 3 as a factor of 6. So I can divide both top and bottom by 3 and simplify. And I get negative 7x squared divided by 2y squared. And I've found the derivative of y with respect to x. Okay, let's try another one. This time it's a little more complicated. You still take the derivative term by term under the assumption that y is a function of x. So the derivative of 3x squared is going to be 6x plus, now the second term is a product, so you want to think of 3x as one term, as one factor, and y as the other, and use the product rule. The product rule says you take one of the factors and multiply it by the derivative of the second factor. The second factor is y, so its derivative is dy over dx, plus then you reverse it and you take the second factor and you multiply by the derivative of the first factor, where the derivative of 3x is 3. So that's the derivative by the product rule. Then you keep going. The next term, y is a function of x, so you use the chain rule. 2 times 9 is 18. Y to the second drops down to y to the first, and then you come in and take the derivative of the base, so that'd be dy over dx. Moving along, y is a function of x, so the derivative is going to be, the derivative of 7y is 7, but by the chain rule you have to go back in and take the derivative of the base, which would be the derivative of y is dy over dx. Then you've got the derivative of negative 9, or minus the derivative of 9, however you want to look at it. The derivative of 9 is 0. And then on the other side, the derivative of 0 is 0. Now I want to clean this up a little, make it look better. And I also want to collect the terms that have dy over dx together on one side. So I'll write this as 6x plus 3x dy over dx plus y times 3 is more commonly written as 3y plus 18y times dy over dx plus 7 dy over dx. And then those are all 0, so you just got equal to 0. As I said, I want to collect every term that has dy over dx in it on one side. Everything else goes over. So I'm going to subtract the 6x from both sides to move that term over, and subtract the 3y from both sides to move that term over. So what I end up with is 3x times dy over dx plus 18y times dy over dx plus 7 dy over dx, and then the other two things move to the other side, so I get a minus 6x and a minus 3y. Now that I have dy over dx in every term on the left, I can factor it out. So if I factor a dy over dx out on the left, I'm left with a 3x from this term, an 18y from this term, and a 7 from the final term. Now if I divide both sides by this quantity on the left, this 3x plus 18y plus 7, I'll have dy over dx. So dy over dx is minus 6x minus 3y divided by this factor here, which is 3x plus 18y plus 7. So now I've found dy over dx for that problem. Let's keep going. This time, I have a product rule on the left. So the product rule says to find the derivative, I take the first factor, which is an x, multiply by the derivative of the second factor. The second factor is y squared, but y is a function of x, so it'll involve the chain rule. So I get 2y, and the 2 comes down to 1, but then I have to take the derivative of the base, and the derivative of y is dy over dx. That's the first half of the product rule. Plus, then I reverse it and take the second factor and multiply it by the derivative of the first. Well, the derivative of x is just 1. And then, of course, the derivative of 4 is 0. Now it's a matter of just solving for dy over dx. So I get, just clean this up a little bit, that's 2xy times dy over dx plus y squared equal to 0. I want to slide the only term that doesn't have a dy over dx to the other side, so I'll subtract a y squared from both sides. And that'll give me 2xy dy over dx is equal to negative y squared. And finally, just divide both sides by 2xy, and I'll have dy over dx is equal to minus y squared over 2xy. And the one thing that you need to be careful about here is there's a y here and there's a y in here, so I can divide a y out of the numerator and denominator. So you do need to look to see if there are any simplifications that you can carry out. And so now I've found the derivative of y with respect to x. Okay, moving along. This is a product rule here, and it's going to be a product rule on the right. But in addition, we also have an exponential, so we've got to remember our rules for derivatives of exponential functions. But not getting ahead of ourselves, the first thing we want to do is treat that as a product rule when we take the derivative. So we take the first factor, which is y cubed, times the derivative of the second factor. The second factor is e to the x, and as you should know by now, the derivative of e to the x is e to the x. Plus, now you take the second factor, which is e to the x, and multiply it by the derivative of the first factor. The first factor is y cubed, so the derivative is 3y squared, but y is a function of x. You've got to use the chain rule and take the derivative of y, and that gives you dy over dx. So that is the chain rule for the first term. Plus, now the derivative of x is 1, that's easy. And then we have to use a product rule on the right. So again, starting with the product rule, we take the first factor, which is y to the fifth, and multiply it by the derivative of x, which is 1. Then you reverse it and take the x and multiply it by the derivative of y to the fifth. That's 5y to the fourth, but remember y is a function of x. You've got to go in by the chain rule and take the derivative of y. And that is the product rule on the right hand side. Now we want to simplify this and make it look a little better, so let's just take a minute and do that. We get y cubed e to the x plus 3 y squared e to the x dy over dx plus 1 is equal to y to the fifth times 1 is just y to the fifth plus 5x y to the fourth times dy over dx. Now what we want are the two terms that have dy over dx in them on one side, so I'm going to slide this over by subtracting. And everything that doesn't have a dy dx in it to go to the other side, so I want to slide that over by subtracting and slide that over by subtracting. So I'll end up with, this stays where it is, 3y squared e to the x times dy over dx. This moves over so it becomes negative, so you got minus 5x y to the fourth dy over dx is equal to, the y to the fifth stays where it is, and this slides over and becomes negative, so you get minus y to the third e to the x, and this slides over and becomes a minus 1. Now that you've got everything with the dy over dx on one side, you factor it out. So you get dy over dx, and what you're left with in the first term is the 3y squared e to the x minus 5x y to the fourth. And then the right hand side is unchanged. Now all we need to do is divide both sides by this factor over here, and we'll have dy over dx. So dy over dx is equal to y to the fifth minus y to the third times e to the x minus 1 all over 3y squared e to the x minus 5xy to the fourth. And there is dy over dx for that problem. Another problem. This one involves natural logarithms. So we've got to remember the formula for the natural log, and then realize that you've got a product rule here and a product rule here. So we start off taking the derivative of that product. It'll be the first factor, which is x, times the derivative. Now remember, the derivative of natural log is 1 over what you're taking the natural log of times the derivative of what you're taking the natural log of. So the derivative of natural log of y, given that y is a function of x, is 1 over y times the derivative of y, which is dy over dx. That's the first half of the product rule. Now plus, you reverse it and take the second factor, which is the natural log of y, and multiply it by the derivative of x, which is 1. So that is the product rule for the first term. Plus, now we're taking the derivative of y. Assuming y is a function of x, the derivative of y is dy over dx. And then we do one more product rule on the right. So you take the first factor, which is x cubed, times the derivative of the second factor, that'd be 3y squared. Since y is a function of x, you've got to take the derivative of the y. So that'd be times dy over dx. Plus, now you reverse it, take the y cubed, and multiply it by the derivative of x cubed, which is 3x squared. Now it's the same as before. We want to simplify it, make it a little simpler. X is like x over 1, so if you multiply those two things together, you get x times 1 is x, 1 times y is y, so you end up getting x over y times dy over dx, plus multiplying by 1 doesn't change it, so it just becomes the natural log of y. That's still dy over dx. Let's write the 3 first. You get 3x cubed y squared dy over dx plus 3x squared y cubed. And it's the same as before. You want every term that has dy over dx in it on the left, and everything else moves over to the right. So that term will end up moving over. This term will end up moving over with the other dy over dx's. So we get x over y dy over dx. That's going to move, but you still have this dy over dx here. And then this is going to move and become negative, so you get minus 3x cubed y squared times dy over dx equals the 3x squared y cubed stays where it is. The natural log of y moves over and becomes minus natural log of y. And then we're going to factor a dy over dx out of each term on the left. And that will leave us with x over y plus, and when you factor dy over dx and there's nothing else there, it's an understood 1, minus, and then you're left with the 3x cubed y squared. The right-hand side is unchanged. Now it's a matter of dividing both sides by this factor here, and you end up with dy over dx equals 3x squared y cubed minus natural log of y all over x over y plus 1 minus 3x cubed y squared. Now we really don't want to leave a complex fraction, so we got a fraction within a fraction, and the easiest way to do that is just to multiply every term by y. So if we multiply this term by y, this term by y, this term by y, this term by y, and this term by y, you can see what happens. You get 3x squared, and then y times y to the third becomes y to the fourth. Then you've got the minus, and that y gets multiplied by the natural log of y. And then down bottom, this is a y, they cancel, and you just get x. And then y times 1 is just a y. And then minus 3x cubed. And then y times y squared is y cubed. And that's really about as simple as you can write it. So dy over dx is going to be given by this expression. Okay, next. This is sort of an application. It says if x squared y squared equals 64, find the equation of the tangent line to this curve at the point 1, 8. In other words, you've got a curve here, and there's a point of tangency at 1, 8, and you want to find the equation of the line. Now remember that you need to write the equation. To write the equation of a line, you need a point, which we have, and the slope, which we don't have. But we can find the slope because the slope is the quantity dy over dx that we've been calculating. So all we need to do, once we realize that, is find the slope. We already have the point using implicit differentiation. So if we go back to this problem, we're going to use the product rule on the left-hand side. So you got the first factor, which is x squared, times the derivative of y squared, assuming y is a function of x. That'd be 2y to the first, but then you've got to come back by the chain rule and take the derivative of y, which is dy over dx. Plus, now you reverse it, you take the y squared and you multiply by the derivative of x squared, which is 2x. And then on the right hand side, the derivative of a constant is 0. Now it's just a matter of simplifying it and writing this with dy over dx on one side. So what we really have here is 2x squared y times dy over dx plus 2xy squared equal to 0. So I want to leave this where it is and move this term over. So I get 2x squared y times dy over dx equal negative 2x y squared. Then if I divide both sides by that 2x squared y, I get dy over dx is equal to negative 2xy squared over 2x squared y. Now I hope you'll notice that this will simplify quite a bit because the 2's will divide out, leaving you with a negative sign up there. This x will go into that x squared, taking the x completely away, and this y will go into that y squared, leaving a y. So up top we're just left with minus y. Down bottom the 2's divided out. This x went into that x squared and left an x, and the y divided into that y squared, so it went completely away. Now that's the derivative of y with respect to x, but we want the derivative, we want the slope at this point right here. So we have to actually take this value of x, which is 1, and this value of y, which is 8, and plug them in here so we'll be able to solve. So let me move over here. So at the point 1 comma 8 where x is 1 and y is 8, dy over dx, and I'll write it this way, at the point 1 comma 8 is going to be negative whatever y is, which would be 8, divided by whatever x is, which is 1. So the slope of the line that we're looking for is just negative 8 over 1, which is negative 8. So now I have the slope of the line and I have the point on the line. Once I have that, I can find the equation of the line in what's called point-slope form. And the point-slope form of a line is y minus y1 equals m times x minus x sub 1. This is like the x of 1, y1, and this is the slope. So if I plug those numbers in, I get y minus 8 is equal to m, which is negative 8, times x minus x of 1, which is 1. And we want to simplify that. So you end up with y minus 8 is equal to, if we multiply the parentheses, we get minus 8x, minus a minus is plus 8. And then if we add an 8 to both sides, we end up with y equals minus 8x plus 16. So that is the equation of the line that they're asking us for. It's tangent to this curve at that point. Let's look at one more application problem. It says the demand equation for a certain product is 2p squared plus q squared equals 1200, where p is the price per unit in dollars and q is the number of units demanded. They want us to find dq over dp. In other words, the derivative of the quantity with respect to the price. So the q is like the y and the p is like the x if you're thinking of dy over dx. So the p is the variable and q is a function of p. So whenever I take the derivative of q, I've got to use the chain rule and think of that as dq over dp. So you got to look at this. The q is like the y and the p is like the x. So looking back at the equation, p is like the x, so the derivative of 2p squared is going to just be 4p, plus the q is like the y, so it's a function of p, so the derivative using the chain rule is 2q, the 2 goes to 1, but then I've got to take the derivative of the inside, which is dq over dp, the derivative of the quantity with respect to the price. And then of course the derivative of 1200 is a constant. The derivative of a constant is always 0. Now I'm going to move the 4p over by subtracting, so I'll get 2q times dq over dp is equal to negative 4p, and then divide both sides by 2q, and I get dq over dp is equal to negative 4p over 2q, and of course there's a 2 inside of that 4 as a factor, so I can divide that out. So I get dq over dp is equal to negative 2p over q. And now I have found what they asked me to find.